Hey guys, this is Ian Fernandez, and this is the first presentation in a series of presentations or lectures that cover some of the major topics in UIL Computer Science. And so today we're going to start off with the topic of sorting. So let's get into it. The main thing that we're going to deal with when we are sorting in UIL problems is collections.sort. So this is basically an easy way to sort a list it provides an easy way to sort a list based on natural ordering. So for example, you can sort wrapper class variables like integers, characters, doubles, strings, etc. So on the right here, you can see how you simply create a list for your wrapper class. Here we're using the integer wrapper class. Here I just plop in 4135, right? Print out the list before 4135 as expected. Then we use collections.sortList, and what this does automatically is it sorts all of the elements within the array list in their natural ordering. And so for integers, that's from least to most, or lowest to highest. And so when we call collections.sort on a list, and we print the list after that, you'll see that the list is now 1, 3, 4, 5, which is in order. So you'll see that the collections.sort method, it sorts the list by itself. This does not return a new list that you have to store in list. When we call collections.sort of list, nothing else, that'll change the structure of list by itself. And so once you call that, when you print the list again, it'll change. So that's one way you can use collections.sort. But you can also use collections.sort on user-defined class objects. And so that could be an assortment of things. One example is a car, or it might be more commonly in a UIL problem, a person or a customer. These are objects that you will define by yourself in order to make the problem a little bit easier to handle. And so Arraylist can obviously store these user-defined class objects, and as a result, you can also sort them with collections.sort. But there's a little catch to this, because when you create your own user-defined object, it's not like the computer knows how to sort the objects. For example, if you create a student class and you have a variable called name and a variable called age, and you say collections.sort students, the program won't automatically know to sort by name first and then age, or by age first and then name. So in this case, you have to tell it what to do, because there is no natural ordering that is automatically defined. And so there are a couple of ways to do this. One is to implement the comparable interface, and the second way is to use a custom comparator. So let's start off with implementing the comparable interface. So say we have class A, and class A, it represents our objects, like a car or a person. It should also implement the comparable interface. And what you want to do when you're defining the class is you want to say public class X implements comparable of X. So it's important to include this bracket here and put the class name. And so usually that will just be a replica of the class name here. So if you put student here, student should also go here. And the reason you're doing that is because you want to compare student to other students, right? So naturally you want to implement comparable using the student version of the generic there. And where this comes into play is over here, because when you implement the comparable interface, the only method, it's a functional interface, so there's only one method that you have to define, and that is the int compare2 method. And so basically what it does is the argument is another object that you're comparing this object to. And so if you didn't include this bracket with the student, then this would be object. It would assume that the program could only assume that it's an object. And so then you have to downcast from an object to a student. But if you put student up here, then the computer knows that you're comparing this object to a student object, And so that allows you to just put the student there, makes it a lot easier. You don't have to downcast or anything. Um, and so if you implement comparable student, you have to define compare2 with a student argument, right? And this compare2 method should define how to handle the comparisons between two student objects in this case. And the way this compare2 method works is um, if the first object, which we'll call this, if this object is less than the object up here, which we call other, then we want to return a negative value. If they're equal to each other by the way you define it, by the way you define equality, then you want to return 0. And if this object is greater than the other object that we're comparing to, then you want to return a positive number. So it can be any positive number, any negative number, as long as it is positive and negative. Okay, so in this case, it looks like we are reverse sorting by age in the name. So how do we know that? Because we say if age is not equal to other.age. So if they're not equal, if this age is not equal to other age, then you want to return this age minus other age. And so you think about it, what happens when this age is less than other age? Well, if this age is less than other age, then this whole result will be negative. And so that will be indicative of this object being less than other object. And that's what you want in this case, since we want to sort by age in ascending order, right? So then if the ages are equal, then you want to compare by the other variable we have. So for example, if two students have the same age, then we're going to compare objects by their names. And so then you can return name.compare2other.name. And we know that the name is a string, and so compare2 will correctly return a negative number if this name is less than this name. It'll return 0 if they're equal to each other. And it will return a positive number if this name is greater than this name. And you probably know the rules for those comparisons by this point. So basically what this method is doing in total is it's checking if the ages are the same. If they're not, then we can sort by age. And so we're going to return this age minus other.age. So if this age is less than other.age, then it's going to return a negative value. If this age is greater than other.age, it's going to return a positive value, right? And so we remember that when we return a negative value, that means that this object is less than the other object. And when we return a positive value, we know that this object is greater than the other object. And then if we can't sort by age, and in that case the ages are equal, then we have to sort by name. And so then we would return name.compare2other.name. And so that's how this whole thing of implementing the comparable interface works. You simply, when you're defining your custom object, in this case a student, you just want to add in this implements comparable the comparable interface, and you want to specify student here. And then what you want to do is you want to implement the single abstract method in this interface, which is the Compare2 method. And so the type of this parameter is going to be the same one you put up here. So these are linked to each other. And if you don't have anything up here, it's assumed to be an object. And so you have to have an object here. And then you have to downcast. But if you want to be safe, just put the name of the object you're compared to, which will most likely be the one that you define the class with. And then you just copy that over here, because you're going to be comparing one student to another student. And then you simply define the implementation of how to compare two students. In this example, we sort by age and then name. So this is how you implement a comparable interface in order to use collections.sort. And so let's see, do we have this here? So basically what would happen is if you did this and you added a bunch of students to a list, and then you called collections.sort on this list with no other arguments, then it would know to automatically use the Compare2 method to sort the elements in the list. Okay, so um, because it automatically looks for the compare2 method um, when you call collections.sort. And so that's how it's going to sort the list. Another way you can handle this is by using a custom comparator. And so there's a few different ways to do this. One is to simply define the anonymous function public int compare, a first, a second. It's very similar to what we did before with compare2, but this time we're not going to define it in the class. We could also use a lambda expression, and we can also use comparator.comparing, which is a really nice and concise technique to go about this. So once you define the comparator, then what you do is you simply pass in the comparator as a second argument of collections.sort. So when you're using a custom comparator, this is assuming that you're not implementing the comparable interface in your custom class blueprint. You're instead going to define how to sort the elements after the fact when you're calling collections.sort. So I'll show you how to do this. The first method is using public int compare, and it'll take two arguments. One is the first object and one is the second object. And it's almost the same as compare2, except now instead of being in the class, it's outside of the class, and therefore we need two arguments. We don't have any this anymore. We have a first and we have a second. So if the comparable interface is not implemented by the class in question, we can define the comparator to use while calling the collections.sort method. Okay, so take this example here. I made a custom class called animal, and it takes a single argument in the constructor, and that's the name of the animal, right? And what I do is I essentially add all these animals to a list, an array list of animals, okay? And in this animal class, I did not implement the comparable interface, which means I did not implement the compare2 method. So if I were to just call collections.sort on this without doing anything else, the program wouldn't know how to order the elements. Now here we have the collections.sort method, and as normal, we pass in our animals list, array list of animals. But this time we pass in a comparator as the second argument. And you'll see here, one thing you'll notice is that comparator, you can't instantiate it by itself, right? I believe it's an interface. And that would be a problem, except for in this case, comparator is actually a functional interface, which means there's only one abstract method that needs to be implemented. And so what we can actually do is we can anonymously define that one abstract method here. And so in the comparator interface, the only public abstract method in there is public int compare, the public int compare method. And so that's the only thing that we need to define in order to tell the program how to sort these animals. And so what we have here is we say new comparator, and we input the animal class there so that we're comparing animals to animals. Otherwise, we'd be comparing objects, and we have to downcast to animals, which is not the cleanest code, right? And then here we simply define the public int compare method, and it'll take two arguments. One is a first and one is second. And you'll notice that we can't just last time when we were in the class, we just had, for example, animal other, and we were using this.name, for example. But we can't do that here because we're not inside of the class. Here we're defining a comparator independently, and so we have to pass in two objects, first and second. And the type of both of these variables should be the same one you use over here, just like we had the connection between this variable type and this variable type. So there's lots of connections here. And so here inside this method, again, it's basically the same thing as what we did with compare2. Basically, it's going to return a negative number if first is less than second. It's going to return 0 if first is equal to second. And it's going to return a positive number if first is greater than second. And so that's all you need to worry about. And so in this case, what I say is I say return first.name dot compare to second.name. And so this is essentially just sorting the animals by their name in ascending order. And so this is all that this method is doing. It's very simple, but we'll see some other nice ways of doing this. A quick note here is that you could always define the comparator as a variable first and then pass it in as the second argument of collections.sort. So for example, here we're just defining the method right inside of the function call. But if you like the function call to be a bit neater, then you could before this line here, you could add a another line here where you instantiate a comparator object. And what you say is you'd say a comparator, for example, x is equal to new comparator, and then you put all this here. And then you just pass in x here. So this can all just be assigned to a variable, and then you can pass in the variable instead. It just depends on what you want to do. So that's how you use the public and compare method. So now let's move on to exploiting the functional interface nature of that method with Lambda expressions. So from the previous example, we saw the comparator interface, and we saw that it was a functional interface that only had one method to actually define, and that was the compare method. And so because it only has one method to define, we can actually use Lambda expressions to define the functionality of the method instead of writing the whole method signature and everything like that inside of the function call. And this makes it a lot neater. And so you can see here we're doing the same thing, but in the second argument, now keep in mind the second argument is always going to be comparator. And so this is just returning the comparator essentially. But the way you do this with Lambda expressions is you put the arguments in parentheses, and for each argument you just add a comma and list the next argument that's in here. But for a comparator, obviously, the compare method only takes two arguments, and that's the first element and the second element that you're comparing. So you just say first comma second or whatever you want there, as long as you have two arguments. And then you have the lambda arrow notation. And so this is basically saying you have your first and second arguments of your method, right? And then here is what you're doing with that. So basically in this case, we're going to return this result. So given first and second, this will return first.name.compare to second.name. So again, it's just sorting the animals in ascending order of name. And so this is literally the same thing as we did here, but instead of writing out the whole method signature and everything, we're simplifying it a lot by just saying first and second, because the program knows in the background all this stuff. This is just extra code that you have to write and you have to remember. And so Lambda expressions, they simplify that process a little bit, so you don't have to remember as much. It's very easy to remember the notation. You simply list all the arguments delimited with commas inside of parentheses. Use the lambda notation here, the arrow notation, and then you have the return result here based on these arguments. And so again, this will sort the animal list in ascending order based on name. And again, we could always declare a comparator variable up here and assign it to this expression, which is a comparator. And then we can pass in that comparator variable here. It just depends on what you want to do. And the final method we'll be talking about is comparator.comparing. And this is probably the most intuitive way to define a comparator. I think Mr. Finelio really loves this method too, so that's a plus. And the way this works is you can easily chain on attributes to compare if prior attributes are equal to each other. So what this means is, say you have a student object or student class, right? And you have two instance variables, one is name, one is age. So what we originally did with the compare2 method or the compare method was, we said if the ages are not equal to each other, then subtract the second age from the first age. Otherwise, then you compare names, and that was a bit messy. So for this one, you can easily and very, very, very easily sort, for example, by age, and then by name, and then by ID, and then by whatever else you wanted to. So, sometimes you'll come across a UIL problem where the program just wants you to sort by, name, and then ID, and then age, and then favorite color. There's plenty of programs like that the UIL has released, and so it's good to know this method of sorting because I think it'll be very helpful to you. And so again, we create our student objects. We have a name and an age, and then again collections.sort students, and then here we have our comparator as the second argument of the collections.sort method. So what you're doing here, you just have to write down comparator.comparing, and then what you would have to do is the first parameter or the first attribute that you're comparing, you need to say that using Lambda notation here. So you need to say that the object that you're looking at is a student. And so the way to do that is you just say in parentheses student X. Okay, now that that is taken care of, now that the program knows that X is always referring to a student object, then we can specify the attributes really easily. And so we can say comparator.comparing student X, and then what do we do with student X? We compare X.age. Then, so what that would do by itself would sort the elements by age. Okay. Then here's like another little method that you can use that's very helpful, and it's called reversed. And basically, if you add on dot reversed, it'll basically reverse the ordering of the previous attribute. So if I say X.age here, and I say dot reversed, it'll actually sort the elements by age in descending order instead of ascending order. And so that's very useful in some of these problems. It's a good thing to know. So once you have one attribute out the way, then you can just chain on another attribute, right? You can say dot then comparing X. You take X and you compare. You're looking at the name instance variable of X, and so this chain of attributes can go on and on and on to cover as many as you need. I could say, for example, here, if I was looking at this example, I could say comparator.comparing student X, lambda arrow notation. I could say age. Then I would say dot then comparing X.name, dot then comparing X.id if I had an ID instance variable, right? So it's very easy. This is very easy to follow, and it's the most, I guess, language-like commands, the most user-friendly, human-friendly command that you can use to sort, that you can use to sort in an advanced way, I guess. So yeah, so this is the compare method. I think it'll be very useful for you in UIL problems. It should be very, very easy to just quickly sort by attributes. Maybe the only downfall with this is, if your sorting involves more complex calculations to determine the comparisons between the two objects, then you might want to use one of the methods that we had before, like this functional interface or public and compare or the comparable interface, because it might be easier to write the code in those functions instead of having to write all the calculation code in one line. But other than that, if you're just comparing attributes and every now and then doing it in descending order, comparator.comparing is an excellent choice to use. Okay, so now let's move on to some data structures that automatically sort. The first one that we're going to be looking at is the tree set, and also its tree map, neighbor, I guess. So the tree set is, if you, I'm assuming you know about hash sets at this point. Basically, what the hash set does is it's almost like an array list, but for a hash set, it does not allow duplicates. Okay, so if you input, 5, 5, 1, and 3 into a hash set, the extra 5 would be discarded, and you'd only have 3 elements, right? So tree set's very similar to hash set in that sense, but for a tree set, it also adds in ordering. So not only do you have no duplicates, but you also have it defaulting to natural ordering. So if you have a tree set of integers, um, and you add all these integers to the tree set, and you print out the tree set, um, it will be in order. And for tree set, so if I pass in this just regularly with a regular tree set, and I printed it out, it would print 1, 3, 5, and it would exclude this extra 5, right? Right. Um, but you can also, another cool thing about tree set is you can pass in a custom comparator. Just like we defined comparators in the previous slides, we can pass in a comparator in the constructor of a tree set actually. So in this example, I use the comparator.comparing approach, and what I do is I essentially say, for this tree set, when you're comparing the elements, I want you to sort it by um, the value of the integer in descending order. That's essentially what this code is doing. I'm basically just reversing the order so that it's in descending order. So instead of 1, 3, 5, it's now 5, 3, 1. So that's how the tree set works. It's very simple. It comes up, sometimes it's more obvious when to use the tree set because the program will be quite explicit about not having duplicates and, having an order to it. But other times you'll find some nice sneaky cases that a tree set would be pretty nice and clean to use. Now we also have the tree map. It's kind of like the tree set's neighbor almost. And so what the tree map does, I'm sure you know about the hash map, where it just links a key to a value and key value pairs. And obviously there are no duplicate keys in a hash map. So it's a similar thing with tree map. It's like analogous relationship between the hash set and tree set. It's the same for the hash map and tree map. So again, here you have no duplicate keys. So for example, if I put in 2 key value pairs that both have the same key, it's going to use the last instance of the insertion with that key, with that duplicate key. So for example, if I put 5 maps to 3 and 5 maps to 6, then it's going to ignore 5 maps to 3 because 5 maps to 6 was the last one we put in, right? And so, hash map, there is no ordering to the elements. It can be random. But for tree map, it actually, when you print out the tree map, it will default to the natural ordering of the keys, not the values. So if we put this in a tree map like we're doing here, and we print out the map, it's going to sort it by the key value. So let's say 1, 4, and then 5, right? It's not going to sort it by the value. It's sorting it by the key. That's important to know. And of course, with the tree map, you can pass in a custom comparator, just like you could with the tree set. So here, what we do is we pass in the comparator with the tree map constructor. So here we have, in that parentheses, I usually just leave empty. Instead here, we pass in a comparator. And so we're using the compare.comparing again, and we are doing the same thing. We're sorting them in descending order of key value. Not the value in the pair, but the key's integer value. So instead of 1, 4, 5, it's going to be sorting 5, 4, 1. So here, after you put these in the tree map, you'll see when you print out the map, this is sorting by the key value in descending order. And that's just because of the comparator we passed in. If we did not pass in a comparator, it would instead read 1 equals 2, 4 equals 0, and then 5 equals 6, because that would be the natural ordering of the keys, right? So that's how a tree set and tree map work. There's also a priority queue data structure. Now, it's very unlikely that you'll actually be using this in a hands-on problem when you're in the hands-on portion of the UIL test. You're very likely not going to be coding this, but you might see this on a written UIL test. So we'll just go over this real quick. So basically, how you let's just go over the functionality. So it's almost like an array list, right? Like the functionality of adding. So you just added all the elements in regularly. Like you just use regular dot add, and you put the actual element in there in the parentheses as an argument. And the only stipulation here is that all of the elements must be objects that implement the comparable interface. If you remember from one of our first slides, we were talking about the comparable interface. So each object that goes in a priority queue must implement the comparable interface, which means that it must implement that compare2 method. And integer is, it obviously implements the comparable interface. The Java coders already handled that. But you could also, if you had a custom class variable like student, in order to add it to a priority queue, you would need to implement the comparable interface. And so once you do that, then you can add them in regularly. And so Mr. Familio can go over the what actually happens when you're adding to a priority queue. But most of the important thing here when we're referring to its sorting abilities is when you add all the elements to a priority queue, and then you pull off the elements, then what will happen is they will pull off in natural order. So pull is basically a function of a priority queue. It's kind of like the remove function, for example, of an array list. But the pull function is kind of the equivalent for a priority queue. And so what it does is it removes the element at the head of the priority queue, and it returns the value of it. So basically what happens is once you add all these values here, the way you check if it's empty, one of the ways you can check if it's empty is, while it's not empty, the isEmpty method, right? So while it's not empty, then you print out pq.pull. And so when you do this, when you keep on pulling off until there are no elements in the priority queue, what happens is they pull off in natural order. So here we added in 5, 1, 3, and 3. And when you keep on pulling these off, they'll pull off in natural order, which means they'll pull off in the order as follows: 1, 3, 3, and then 5. Right? That's natural ascending order. And I think there must be some way you can pass in a comparator here, but I didn't mention it here just for the simplicity of this, because this might be a new data structure for you. But yeah, so I'm not talking about the internal representation when you add these elements in. That's a bit more complicated. But if you're only thinking about pulling off the elements and seeing what order they pull off in, they will pull off in natural order. And so this is usually only important for the written UIL test, right? Because if you wanted to get the elements in order, you could simply add all the elements to an array list and then use collections.sort instead of using a priority queue. So really the only times you'll see a priority queue usually is on the written portion of the UIL test. And so basically what will happen in a typical problem is the code will add a ton of values to a priority queue, and it will then pull off the elements and then print them until the structure is empty, just like it's doing over here. And it's going to ask you, what is the output of the code? And so usually what a lot of students do is they get into all the complicated nature of how the elements are structured in the priority queue, and they try to remove each one at a time, which once you find out how the priority queue works internally, it takes a bit of time to do it that way. But if you know that the elements pull off in natural order, then you can easily just sort these element additions in your head or write it down on paper, and then you'll know what the code output is. So that's really the only case for priority queues, but it's nice to know. So just some other quick tips. Usually when you're approaching a UIL sorting problem, it's basically just asking you to sort these different people or items or whatever it is by certain attributes. And so the first thing you need to do, obviously, is determine what is an element for you in this problem. Is your element a student? Is each element in the list going to be a student? Are you going to sort students? Are you going to sort dogs? Are you going to sort pets? Are you going to sort, there's plenty of things and that you would want to sort, or that the problem could throw at you. And so these elements are going to be, what you make your custom classes for. So after determining what each element is, say for example a student, then you want to determine the characteristics of each element. So in a problem, it might ask you to sort by name and then ID number. And so your element is a student, but the characteristics of each element, those are going to be the name and the ID number, right? And so then once you know these two, you're pretty much set for defining your class, custom class that represents that element. And so what you usually do is, that's going to be a static inner class within the class that you're coding. So obviously, for example, if the UIL program name is John.java or something like that, you have your class John, but then you have a static inner class within John. That you're basically defining a class within a class, and that's going to represent your. That's one way you can do to define your custom objects. And so you just say inside of the outer class, you'd say static class and then student, for example, and then define that class. That's one way you can do it. But either way, you're defining a class, you know what the element is, and you know what the characteristics of each element is. And so for the characteristics, those are equivalent to the instance variables within that class. And so you're basically going to define the instance variables to represent the characteristics identified at the beginning. So pretty easy so far. You're just defining the custom class there. So once you do that, all you have to do is you have to process through the input file, go through each line. For each element that there is, you want to create an object for it using the constructor appropriately. And then you just want to add that new object that you made to an array list of that object. So for example, if your elements are students, before you process the input file, obviously you want to make an array list of students that's empty. And then while you're going through the lines of the text file or DAT file that you're analyzing, you're just going to want to say, your list.add new student, and then have all of your constructor arguments filled in. So once you add all the objects to the array list, then you simply use collections.sort on that array list. And with this method, we're obviously dealing with custom objects. And so a really easy way to go about this is using that third method I described to you guys, which is the comparator.compare method. And it should be a very easy, very simple way to go about sorting the elements. And then usually the last thing you do is you loop through the elements of the list now that they're in order, and then you print each element as the program specifies. So this is your basic outline to approach a UIL sorting problem. It's not too bad. It's pretty simple, especially when you're using the comparator.comparing method. And as long as you know how to define these classes, maybe you had some experience in AP CSA, you should be fine with these sorting problems as long as you follow these general guidelines. And then another tip is, we have a repository of UIL solutions on GitHub. It's hosted on a GitHub repository. And it's really just an excellent resource to consult when you need help understanding how to solve a certain type of problem, or you might just need a better or faster way of doing it. It's always nice to check what other team members have put on the repository. If you're maybe solving the same problem, if you're having trouble with it, maybe you can take a sneak peek at their solution and then figure out how you might want to approach it your way, or anything like that. Or you might just use it for, studying right before a UIL competition, which can be very useful because in the GitHub repository you have all of the code and it's sectioned out in these directories, um, and each directory is representing a different subtopic. And so this is a very useful site. Here is the URL for that. Um, and if you need that URL, you can also get it from either me or Mr. Fenolio. And also, if you want to be added to this GitHub repository, you know, uh, to contribute code solutions to it, then just go ahead and email me or Mr. Fenolio, and we should be able to get you added on there. So now that we, got through the lecture, let's get to coding. Alrighty, so let's go ahead and get started with the first problem that we're going to be looking at today from this A+ packet. We'll start off with 50. We'll just take it to the end. So let's say PR50 is here, sorting letters. Okay, what do we need to do here? It says to write a program to print out the letters of the string alphabet in a sorted list of letters. No input, and all right. So basically what it wants us to do is just print out those letters in alphabetical order, right? From A to Z. So that shouldn't be too hard given what we learned in the presentation. So right now, if you want to pause the video and try to work this out yourself, and then you can come back to the video and work it out with me. Or if you don't know how to approach this problem, then just stick around and we'll solve it together. Okay, so at this point, let's go into Eclipse. And I just have a quick workspace and Java project set up here. And I have all the dat files that we'll need for today's, all the input files here. So let's go ahead and create a new class, and we'll name it PR50. And we'll also go ahead and just automatically create that main method. I'm just going to add Java import java.util and IO. That should take care of everything for today. And then we don't have to add in the throws IO exception because we're not reading an input file. We'll simply store the word alphabet in a string variable, and then we'll manipulate it from there. Okay, so now that we have this done, what's one way we can approach this? Well, if we want a basic way to do this and we want to go off what we learned in the presentation, we could add each character in Word to an array list of characters. And then we can go ahead and collections.sort that array list. So let's go ahead and try that approach. So we're going to have to set up our array list of characters. I'll just call it chars. Alright, so now that we have our array list set up, we have to loop through each character in Word and add that character to the array list. So we'll just use an enhanced for loop here for char C and word.toCharArray. That's an easy way to do this. It basically returns an array of the characters in the string. So for each character there, we simply say chars.addC. Okay, so now that we have our array list filled up the characters, now we'll just go ahead and collections.sort it, and we don't have to have a second second argument here because we're sorting it in natural order, right? We're going from A to Z, so we don't have to specify a comparator or anything like that. It'll default to natural ordering, and that's what we want in the program. So this should go ahead and sort the list, and all we need to do then is simply print it out all on one line, no spaces. We can just use another for loop for that, right? So we'll say for char C in chars, we'll go ahead and print C. And what we're actually going to do is we'll take off that ln so that they all print on the same line. And I guess we don't need that. Anyways, so let's try running this. Okay, so here's our output on the bottom, AABEHLPT, AABEHLPT. So it looks like our program worked, so that is awesome. Let's move on to PR51. It says to write a program that removes the duplicate letters in a string and prints the remaining letters in alphabetical order. Okay, so the first line of the data set is an integer that represents the number of lines that follow. Each of the remaining lines contains a string of one or more words consisting of only uppercase letters of the alphabet and exactly one space between words. So we want to output the unique letters of the string in alphabetical order. No spaces will be output. Gotcha. Okay, so again, just go ahead and if you have an idea of how you want to approach this, then try to code it yourself. Otherwise, we'll code it together. All right, so at this point, let's just go ahead and do this together. So we're on PR51 now. Let's see. We'll make a new class. Call it PR51. Do all the basic stuff there. We're going to need the IO one now because we're going to be reading it from a file, which means we're also going to need to throw an IO exception there, or specify that it can throw an IO exception. So we'll have our scanner, and we're going to be looking at pr51.dat, and I just have that file up here. I already have everything loaded up, so that should be the same thing that's in the program packet that we just looked at. All right, and the first line in that input file is the number of lines we have. Okay, so we'll say int n is integer.parseInt scan.nextLine. Now let's take the next line, parse it as an integer, and then we'll say while n minus minus. This is a quick way to run this loop n times without having to construct any other variables or anything like that. So that's a nice clean way to do that. Okay, so for each line, what we want to do is, the first thing we'll do is we'll scan it in, right? Okay, so string str is equal to scan.nextLine. Then if you notice here, we're not processing each word separately. We're processing the whole thing together, right? And so we want to be looking at the characters across all the words. And so and you'll also notice that we don't want to take into account spaces, right? Even if a space is there, we should not print it, even if it's like a unique character. So what we could do here is we can replace all the spaces with nothing and pretend that the spaces aren't even there. So that would help us out a little bit. So we can say str is equal to str.replace. I will replace our single space. It says it's a single space in the program. We'll replace it with an empty string. Right, so now we're considering the entire line. We're considering the line as a whole, because there's no need to worry about individual words. So now that we have this, it says it wants us to output the unique letters of the string in alphabetical order. And if you remember from the presentation, there's a really nice data structure for doing this, and that is the tree set, right? Because the tree set will it'll take out duplicates, so there'll only be unique copies of elements there. And at the same time, it'll keep them in natural order. And over here, it says it wants it printed out in alphabetical order. So this is kind of a perfect use case, a classic use case that's hinting at a tree set, right? So let's go ahead and make a tree set of characters. And we'll simply add all the characters to the tree set. And at the end, it should be in the order we want. So we'll say tree set of characters set is equal to new tree set. And now we need to add each character to the tree set. So we'll say that. Go ahead and add a character. Okay, so now we added all. So now we only have unique elements, and it's in sorted order. So that's what we want. And so now we just have to print it out all on one line. We have to print out all the unique ones, all the unique letters on one line. So we'll use a bit of lambda here. This is instead of using a enhanced for loop. This is a nice way to do this. And you'll probably be getting into Lambda Expressions a little bit more as you progress through the UIL program. So we'll go ahead and do this. So for each element x, we will print x. There's an even cleaner way to do this, but this is the pretty intuitive way to see. For each element x, we're calling each element x, and we're printing x for each one in the set, right? So x is a character, we're printing each character in the set. So this is basically just printing out all of the characters in the set in the order that the set's already in, right? So now that would print out each line. Then we just need to add a new character line at the end. So we'll just say don't know what happened there. We'll say ciso, and yeah, that should print us a new line there, new line character. So let's see if this works out. Okay, so ACDEF, IKLO, PRST, and I'm sure if you go through the rest of them and match them up, you'll find that they will be exactly equal to each other. So I think our outputs match here, and I think we solved what the program or the sheet wanted us to solve. So that problem's done. PR51's done. Let's move on to PR52. So let's make a new class here. We'll say PR52. Let's do the basic stuff. Alrighty. And that one. PR52.dat. Okay, and just noticing right away we have the number of lines as the first line, so I'll do our classic setup here. Alrighty. So PR52 says, write a program that removes the duplicate letters in each word of a string and prints the remaining letters in each word in alphabetical order. Okay, so I think this program is basically the last program, but now instead of dealing with the whole line, we're doing it for individual words. Right? I think that's what's happening here. So we just basically need to make a tree set for each word, and we should be all set. Okay, so let's try doing this. We'll go here. And let's see. Okay, so for each line, what do we want to do? Well, now we want to process each word instead of the whole line, and each word is separated by space. And so what we can do is we can split the line on a space. Right, so let's try doing that. So we'll make an array of strings, and it's going to contain the words, and this is just going to be the next line dot split on a space. Right, so that's that. And then what we want to do is for each word we want to make a tree set. So what I'm going to do is I'm going to say for string word in words, Sorry, there's a little bit of Python coming back to me. So for string, word, and words, we need to create the tree set and everything. So this is a good case that we can actually just write a function to do this and call a function. So we'll make a function or a method called process. So we'll process word, and what I'm planning that will do is it will print out this part, and then what I'll have to do after that is I'll need to print out a space. Okay, so this is process, then I have a space, and then process is called again. Okay, and the space at the end here shouldn't matter. And then after each line, we'd want to create a new line character. So that would be here. Right? So now let's take care of process, which will basically create a tree set for each word and print the tree set's contents out. So we'll say we'll just make that. It'll take a string called word in. We'll have a tree set of characters. And for char c in word.toCharArray, we'll say set.addC, chars.addC. Oh gosh. Okay, so now that we've added each character in the word to the tree set, we simply have to print the tree set out. So we'll do the same thing that we did last time. And this time I'll actually use the cleaner way of doing this. And it's not set, it's chars. So this is basically doing the same thing. Before we were saying x and then the arrow notation and system.out.printx. This is basically, it's a much cleaner way to do that if you're simply applying a single method to each element in the collection. You can ask Mr. Finoli a little bit more about this, just another nice way to do it. So anyways, we create the tree set for each word, we add all the characters in, and then we print out the tree set. Then we print out a space, we continue with the rest of the sentence. After the sentence is completed, we print a new line and continue on. So let's see if this works. Oh, okay. We actually have a line L on there. We just want to print one space. Okay. So we have EPRT, EIPR, CDEIKP, blah, 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 EPRS. I'm going to assume a lot of this matches up. AEG. Yeah, so I think we're good on this problem. The output looks like it matches up with what this sample output has. So I think we solved PR52. And let's go ahead and move on to PR53. It says, write a program that removes all the four-letter words from a sentence. Okay, outputs the remaining words in order on one line, and then outputs all the four-letter words in alphabetical order on separate lines. The first line of the data says an integer that represents the number of lines that follow. Each of the remaining lines contains a sentence less than 60 characters long and words separated by a single space. Okay, so basically we remove the four-letter words, we store them somewhere else, and then we print any other word that's not 4 letters long in their order that we encounter them in. And then for the remaining 4-letter words, we actually will print them out in alphabetical order on each line. Okay, so that's not too bad. Let's get into it. This is PR53. Class PR53. Let's do this. Imports. And we have this. And we are pr53.dat. We have a number here that says the number of test cases, if you will. So we'll do that and that. Okay, so now we're looping over each line. Okay, so we want to process each word separately, so we'll do the same thing we did last time. And what that was is we'll create the words array. We'll split on a space. Then we need to iterate over each word. Okay, so we have to store the 4-letter words somewhere, right? So all we have to do at the end is we have to print them in alphabetical order. So what I'm thinking is whenever we encounter a 4-letter word, we'll add it to an array list, right? And then we'll skip it. Other words will print out. And then at the end, what we'll do is we'll sort the array list, collections.sort the array list, and then print out the elements in order. So let's go ahead and try that. So string words equals scan on next line at split. Okay, so we have all our words there. So let's make an array list of strings. And this is our 4-letter words. And so let's loop over each word there. So if word.length equals 4, then we want to add it to the 4-letter words array list, right? Otherwise, we just want to print it out. Oh my gosh, what is that? I don't know what's happening there. Anyways, okay. So otherwise, we just want to print out the word with a space after it, right? So we'll say word plus space. Otherwise, we add it to the array list. Okay, so once we've processed that, now we have all of our 4-letter words in the array list. So, okay, actually we have a space at the end, so we want to actually print line at the end first. Let's get that over with. Then we want to collections.sort the 4-letter words. And then for each one, 4-letter words dot for each. We'll print each one on a separate line. Okay, I'll take care of that. And then we want to print an extra line between the test cases. All right, so let's see if this works. Fourth end is 2, 9 time, is the if all is not, evil Java root that, contains at least 1 letter, each forward. Okay, so everything matches up, so I think our program was successful. Let us move on to PR54 then. The administrator of a summer swimming program has enrolled swimmers for swim classes. As the students are enrolled, the administrator simply listed the instructor followed by the swimmer on a sheet of paper. You need to write a program that will list for each teacher the students in his or her class alphabetically. The first line of the dataset is an integer that represents the number of students enrolled. Each of the remaining lines contains the teacher's name, or the instructor's name, followed by the student's name. All letters are uppercase, okay? So let's see what's happening here. So this is the instructor, this is the student. Right. Mary, okay, Mary, Tom, and Anne. Okay. Mary, Tom, and Anne are the only instructors here. So we want to print out the students in order, alphabetical order. That's easy. But it also looks like they're printing out the instructors in alphabetical order. I'm not sure if they say that here, but if you see here, we actually encounter Mary first, but Mary, the instructor, doesn't happen until here. So it looks like we need to sort the instructors and the students. So let's go ahead and tackle this. This is PR54. Okay. I guess we have the N, right? Yep. Okay. So for each line we have a teacher and a student. So let's do that. So we have string teacher is equal to scan.next, and then a student is equal to scan.next. So what I'm thinking is what we can do is we can make a tree map, right? Because a tree map, let's make like a tree map of a string to an array list of strings. The string, the key, will be the instructor, right? And the value, which is the array list of strings, that'll contain all of the students of that instructor. And the tree map will actually be nice. It'll be better than a hash map because it looks like they're sorting the instructors. So they're sorting the keys. And so the tree map automatically sorts our keys. So that takes care of that issue. So I think our tree map is a way to go here. So it's a mapping from the instructor to a list of their students. So let's go ahead and try this out. Okay, so what we'll actually do is we'll make a tree map after this. It'll link from a string, which is the instructor, to an array list of strings, which is an array list of students. And we'll just call them classes for now. New tree map. Oops. Alrighty. Okay, so we take in a teacher and a student. So when we have we want to see the teacher, right? So if the teacher is not already in the classes tree map, then we want to go ahead and add a new entry in for that teacher. We need to create the key if it doesn't exist, right? So we'll say, I think Mr. Fenolio has a better or more clean way to do this, but this is the most basic and intuitive way to do this. So you say if classes dot contains key teacher, then we'll say classes. So if it already contains teacher, then we just need to get the array list and add the student on, right? So we'll say classes dot get teacher dot add student. That'll get the array list of the associated teacher and then add the student to the end of that array list, right? Otherwise, so we'll say else, if the key doesn't exist, then we'll have to make a new entry. So we'll say classes, I guess, dot put teacher. We'll have to make a new array list, and then we'll need to, in that array list, we'll need to add the one student that we have. So what we could do is we could obviously do this, put an empty array list, and then get that array list and add the student on. But another neat way to do this is just say arrays.asList student. So arrays.asList basically, when you do this inside the constructor, it basically allows you to specify the elements within the array list within the initialization of the array list. And so we're just gonna, this basically just stores student as the only element within this array list. If we had more elements, then we could just delimit them with commas. We only have one student when we set up a new instructor because we're going line by line, and each line has a different student. Okay, so if it doesn't contain the teacher yet, we put the teacher in, and we put their student there. Awesome. So now we have our tree map set up, which links from instructors to students. So the instructors will be in order, so that's good, but we still need to get the students in order. So I think what I'm thinking we'll do is we'll loop through each key, which will be in order, and then we'll grab the array list and we'll sort the array list and print it out. And obviously we'll follow the specifications that this program problem statement wants. Okay, so the way we do that is we'll say for string teacher in classes.keyset. So keyset's going to return a set of the keys in the tree map, and you don't have to worry. It'll return the elements in order. So this will return the this will be just like how it is in the tree map. The keys will be sorted. Okay, so the teachers will be sorted. That's good. So for string teacher in classes.keyset, then we need to grab their students, right? We need to grab that teacher's students. So ArrayList string students is equal to classes.getTeacher, right? Okay, so now we have the students. Let's go ahead and sort the students while we can. So now we have a sorted list of students. Awesome. So now all we have to do now is just print them out how the program wants. And so the program wants us to first print out the teacher. Then it wants us to print each student on a new line, but with 3 spaces, indented 3 spaces before the. Okay, let's do that. So we'll say students.forEach. Okay, so we can't use our neater notation here because we have to. We have to add 3 spaces before each one. So we'll say for each x, for each element. Whoa, that was weird. For each element, we print 1, 2, 3 spaces plus the element. So 3 spaces plus the name, each one on a new line. After we're done processing that constructor, we have to print another new line to separate them out, to separate the instructors out. And I think that should be it. So let's go ahead and run this. Okay, so we start off with Anne, nice. Joe, Marshall, Nick, Mary, Ann, Bob, Richard, Robin, and Bob, Richard, Robin, and Tom, Angela, Dick, Rick. Nice. Okay, so that worked out just fine. So I'll run a bit of a speed run here so we can try to get this done as soon as possible. Let's move on to PR55. So the problems are starting to get a little bit harder, but the principles behind them are what we already learned. So the knowledge is already within you. Oops. Oh my gosh. All right. Again. Oh, I see. I forgot to press the shift key. I think I need to charge my keyboard. Keeps on doing that thing where it duplicates the letters. Anyways. Scanner. This is PR55. Okay, we have our N. All right, so we're all set up there. Okay, what do we have to actually do? Write a program that will read a list of positive integers. The integers in the first, third, fifth position are to be printed from low to high, and the integers in the second, fourth, sixth position are to be printed from high to low. The first line of the data set is an integer that represents the number of lines to follow, blah, blah, blah. I see. I'll put the integers in the odd position from low to high. Okay, so we do all the odds first, then we print a caret sign, and then we do the evens. So the odds are from low to high, ascending order, and the evens are from high to low. And keep in mind that these positions are 1 based, it's not 0 based. So index 0 is actually an odd position. because it's the first element. Okay, I see. So basically 1, 3, okay, and then 6. Okay, gotcha. Okay, so this is let's see if we can just wrap our heads around this just to make sure, that we know what we're doing here. And hold on, let me see if we can get this to work. So if we have 1, 5, 3, 77, so say 1, 5, 3, 77, 45, 32, 45, 32, 6, 8, 8. Okay, so this is the first test case in our sample input. So let's just see what it wants us to do. So obviously this is index 0 and 1 and so on, right? But the position that we actually care about is index plus 1. So that's the first number, the second number. So we don't care about that. We just care about the second one. We care about this one here. So let's see, let me get this back to black. All right, so it wants us to print out the numbers in the odd positions in ascending order. So what are the odd positions? It's 1, 3, or hold on, let me put this in a certain color. So 1, 3, 45, 6, 8. Okay, so basically we're starting from the first element and we're skipping 1. So we could say like int I equals 0 and I plus equals 2, okay? And then, so that would be in ascending order. So let's go ahead and take care of that. All the green ones is 1, 3, and then we have 6 over here, and then 8 over there, and then 45. So that's how we print that out in order. Let's make sure that matches up. 1, 3, 6, 1, 3, 6, 8, 45. 1, 3, 6, 8, 45. Okay, awesome. Then we'd have our little caret sign. Obviously, we're going to ignore these commas. And so now we're dealing with the even positions. And so for the even positions, what it wants us to do, so let's look at the even positions first. That's this number here, this number here, this number here, and this number here. So basically what we're doing is we're starting from the second element, or index 1, I equals 1, and then we're skipping to every other one. So I plus equals 2. Okay, so from these blue ones, let's write this over here. We want to write these down in descending order. So that would be, I'm just going to finish off it here. 77. Okay, that's taken care of. And we have 32, right? Looks like 8's the next biggest one, and then we have 5. All right, so that's what we're doing. So let's make sure that's what the program wants. 77, 32, 85. 77, 32, 85. Okay. So now that we know, what's happening here, I think it'll be a lot easier for us to go ahead and program this. So, if you're ever in UIL competition and you're trying to wrap your head around what the problem is actually asking of you, like what you're actually supposed to do, the coding might not be hard, but trying to understand the problem's intentions might be. It's never a bad idea to just draw diagrams, draw test cases, and see what's happening. So anyways, let's, which program was that? That's PR55, so let's get into that. PR55. Okay, so we're running through each line, and we have each number separated by a space. So we're going to split, okay, just like we did before, we're going to have a string array at first. So we'll say string numbers, because this is all the numbers, but they're going to be in string form. We're going to split on the space. All right, so we have each number as a string. Let's make an array list. Let's do this. Let's make an array list for the odd position numbers and an array list for the even position numbers. And then we'll add the odd position numbers to its respective array list and the even position numbers to its respective array list. And once we do that, at the end we can sort the odd position numbers array list in ascending order and the even position numbers array list in descending order. And then we can go ahead and print it as the program wants. So we have an array list of integers, and this would be the odd position numbers. And it's going to be equal to new array list, blah, blah, blah. And array list of that, even position numbers. All right. So now we need to go through each one. So we need to also keep track of the index, right? So we can't just use an enhanced for loop, because that would have, we wouldn't be able to access the index. We need to know what the index is to determine whether we put it in the odd position numbers or the even position numbers. So let's use a regular for loop. So we'll say for int I is equal to 0, I is less than string numbers dot length, right? Because it's an array. All right. So we want the position, right? What is the position? It's not index. The position is index plus 1, so I plus 1. Okay, that'll take care of that. Then we want to check. We want to say if the position is odd, so if position mod 2 equals 1, what do we want to do? We want to add it to the odd position numbers array list. And we want to add the integer version of it. So we can just say integer.parse int string numbers of I. Otherwise, it must be an even number, but the position must be even. And so then we can just say even position numbers dot add that thing there. All right. So if position is odd, we add to the odd position numbers array list. If it's even, we add to the even position numbers array list. So now we have each array list filled in. All right. So now what we want to do is we want to sort the odd position numbers in ascending order and the even position numbers in descending order. So let's do that. So collections.sort odd position numbers. So we don't have to specify comparator here, because it's actually sorting. We want it to sort in natural order, which is ascending order, for the odd position numbers. But for the even position numbers, we want to do the same thing, but we want it in reverse order. And so there's a nice little shortcut for that. We'll do this, collections.sort. Okay, so obviously this first part's the same as we went over in the presentation. The difference is when we add the comparator here. So we want to sort even position numbers, but we don't want to do it by natural ordering. What we want to do is we want to do it in descending order. And so you could construct your own comparator, custom comparator here, and go through each element and each character in this string and do all that. Or actually, these are integers that we're dealing with, right? Yeah. So you could basically you can make your own comparator as we saw in the slides. But a quick little shortcut for that, there's already a comparator that is defined in Java, and that's collections.reverseOrder. That'll basically just take whatever it's currently sorting by, which is natural ordering, and it'll reverse that order. So collections.reverseOrder actually returns a comparator, and you can use that as the second argument of collections.sort, and it will sort the collection, in our case an array list, in descending order. So that's the way to do that. So it's natural order, but it's reversed, and that's what we want for those even position numbers. Now that we have that done, we just want to figure out the printout. So it looks like for each element in the we want to handle the odd positions first. We'll just print out the element, add a space, right? It's not too bad. So odd position numbers dot for each. We just want to print out the element, add a space, right? Then eventually, once we're done with that, we have a space. We already have a space at the end. Then we want to print out the caret symbol. So we just literally just print out the caret symbol here. And let's just also print out a space before starting the next one. Okay, we've done that. Now we need to take care of the even position numbers. So let's go ahead and do that. And we'll just print each number with a space. After we get to the end of the line, we want to print a new line character so that we can continue with the next test case. So this should work. Let's see. Oh, because we accidentally printed a new line after the caret symbol. My bad. Okay, so 136,845, 136,845 caret 773285, 773285, and the same thing here in the second case, 2344567, 2344567 caret 9877655, 9877655. Okay, so our program was successful. Let's continue on to PR56. Just hang in there for a few more programs, and then we'll be done for today. Let's see. So now we're doing PR56. All right, let's get our imports taken care of. All right. And we have our end there, so let's just take care of that right now. Okay. PR56 says, write a program that will sort a list of integers and output them with the smallest first, the next smallest last, the next smallest second, the next smallest next to last. Okay, so this is a bit more trickier, right? A bit more tricky. So let's see. The first line of the data set is an integer that represents the number of lines that follow. Each of the remaining lines contains integers separated by a single space. Alrighty. So let's just load these let's load these integers in. So we'll do the same thing as we did before. Split on the space, right? Now, if you ever are unsure if it's a space or it could be a tab or two spaces, you could just use this bit of regex there. So that's a white space character, one or more. So that'll cover spaces, tabs, and one or more of them. Just in case, you might see something like that in the future. But you really only need to like type in a spacebar there. All right, so let's think about what's happening here. I think that might be useful. Can we like create a new one? Don't save. All right. So we have 1542, 1542, 1542, and then 37689, 37689, 10. Okay, so the first smallest is first, the next smallest is last. Will that be 2, I guess, right? Does that match up with? Yeah, okay. The next smallest, which is 3, is the second one here. The next smallest is, what, 4? That's the second last. And then next one is 5. That's third. Next one is 6, third last. And 7. And 8. And then 9. And then 10. So I think that's what's happening here, right? 1, 3, 5, 7, 9, 10, 8, 6, 4, 2. So hopefully you understand what's happening here. There's probably a few ways we can do this. Obviously, if you have an idea of what you want to do, just go ahead and pause the video, and we'll come back and go over it together. How about we just add all of the numbers to an array list of integers first? I think that's a good start for us. So we'll turn them from an array list of strings to, or an array of strings to an array list of integers. So we'll say array list and we'll just load them all in. So we'll say string num in next line numbers.add string num. Oh, but we need to add an integer, right? So it would be integer.parseInt string num. All right. So the first thing we have to do is we have to get these sorted, right? We have to know which one is which one's you know, the first smallest and the second smallest and the third smallest, because that'll determine what we do. Yeah, it'll be easier to just have it in order. That's the first thing we need to do. So we'll just go ahead and say collections.sort numbers. Now that we have it sorted in order, now we can do all the more crazy stuff where we put the first the lowest one first, and the next lowest one last, and the next lowest one second, the next lowest one second last. So let's do that. So what can we do here? Okay, well, let's make an array list that'll have the output, that'll have the final version of the array list that we want it to put it in. Because I think when we're adding it, you know, first and last and second last, I think it'll be nice to be able to use the methods of an array list to do that. So let's store it like that. So we'll say array list of integers output list. So this is the list the list that we're going to edit and we're going to print out at the end. And this will contain it in the order that the program wants it in. So we'll do that. Now let's think about this. Let's go back to our little paint program here. We need to sort this, right? We've already sorted this, so that would be the sorted version of this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's what we did, collection.sort. So let's see. So just as a reminder, we want to get from this sorted list there to this output list. Well, I think one way we could do this is we add, because in order to get from here to here, we could, for example, add every other character starting from the beginning. So we add 1, we add 3, 5, 7, 9, and then we can't do anything farther than that, right? And then what we could do is we could start from the end. So once we add them, we delete them, obviously, right? 1, 3, 5, 7, 9. And then what we could do is we can start from the end, and then we can just go in reverse order, and no need to skip any elements since we already removed the ones you've already added. So then we'd add 10, and then we add 8, and then 6, and then 4, and then 2. So I think This is one way we can do this. Of course, there are several ways that this can be implemented, but just looking at the patterns here, um, I think this will be a fine solution for us, at least to cover together. So let's go ahead and implement this in the code. All right, so we have our output list. It's empty. We have our numbers list that's sorted. So for int I is equal to 0, I is less than numbers dot size, I plus plus, let's say output list dot add numbers dot remove I. Okay, so why does this work? Why do we not have to say I plus equals 2? Right, this is when we're going the first time, saying 1, 3, 5, 7. So why do we not have to say I plus equals 2? Well, think about this. If we start from I equals 0, okay, so we remove 0, we add numbers dot remove 0. Okay, so we add 1, and you remove at the same time. Then when we increment I to 1 from 0, so this element's gone, right? Then you're just left with this. And now when you increment it from 0 to 1, 1 is now looking at this element here, right? And that is really the skipping one element from the beginning. And then we say when you delete this one, and then you look from here, it's the same thing. When you increment that value, this value here becomes the index of the previous one. And so when you increment it by 1, we'll now be looking at this one, which is essentially skipping this one over. I hope that makes sense. If not, you can just you can just trace the code out, and you'll see that it's actually skipping every other one here, while deleting the ones that it's adding to the output list. So anyways, that's that. So that's the first round through. And that takes us to 9, right? In this case, it takes us to 9. Then we start from the end, and we just print out everything that's remaining in the list in reverse order. So then we can say for int I equals numbers dot size minus 1, I is greater than or equal to 0, I minus minus, right? The classic way to do this. Then we can say output list dot add numbers dot get I. No need to remove the elements on our way out, because there's no other processing of the numbers list after this loop. Okay, so we just go through the numbers list in reverse order with the elements that are left, and we add them to the output list. And that's exactly what I described over here. Okay, so once that's done, we have our output list. Now all we need to do is print it out with a space separating each integer. So let's go ahead and do that. So we'll say output list for each, and we'll just print an x plus space. And then, of course, we'll need to print a new line character at the end. And that should take care of us. So I guess we'll see if this works. Oh. Which program is this running? Oh, did I accidentally run it on troubleshooting or something? Huh, interesting. Anyways, 13579, 13579, 108642, 108642, 134689, 134689, 151714, 87542, 24567, 1213, 1514, 12, 97654. Okay, so everything looks like it matches up. Not exactly sure what's happening here. Must have been some troubleshooting thing, debugging, I don't know. But our output matches up, so let's go ahead and keep going on. We're almost done. We've got 3 more problems to go, I believe. So let's do this. PR57. PR57 is here. And main method. All right, we have our n. All right. Write a program that will print the names of students with the last name first. Okay. The first line of the data set is an integer that represents the number of lines that follow. Each of the remaining lines contains a person's name in the form of first name, middle name, and last name. Okay. The middle name is optional, and all students will not have a middle name. Output the names alphabetically by last name in the form last name, first name, middle name. All right, so this seems like a classic one where we literally just make a class that represents a student, and then we go ahead and collections.sort with our custom comparator. So let's go ahead and do that. So before we move on, each student has 3 attributes: last name, first name, and middle name. So those will be our instance variables in our student class. So let's do that. So remember before, what I discussed was making a static inner class. So we'll make a class called student. There's no need to make the class out here outside of PR57. We can do it right within PR57 as a static inner class. If you add the static here, it basically the class that you define basically acts like it was defined outside here. But you can when you add static, you can put it inside of PR57. So that's always nice. Anyways, so we have our instance variables first, middle, last. Now not all students have a middle name, but we're just going to set that to an empty string if they don't have a middle name. And you'll see why that is pretty helpful later. So public student string. Okay, so there's 2 cases we have here, right? In one of our cases here, we can get all 3, first name, middle name, last name, but in some cases we don't have a middle name, right? So let's overload the student constructor to take, one of them will take the first name and the last name, like this. The other one will take all 3 names. So we'll say this dot first is equal first, this dot last is equal last, and let's set this dot middle to an empty string. And then we'll make another constructor that we could call, which will be first, middle, last. And this will basically be the whole deal. All right, so we have our student class. That's it. We don't have to do anything else with our student class, right? Because we're going to define our comparator down below. But we could, if we wanted to, we could, implement comparable and then implement that compare2 method. But it's just easier if I'll show you why it's easier, because we're going to be using comparator dot comparing, and so that's going to make it a lot easier and easy to read and easy to code too. You don't have to remember some of the other things of the compare2 method. Anyways, so we have each line. Let us take in the next line as an array of words. So each name of a person will be an element in this array. So sometimes the array will contain only the first name and the last name. Other times it will contain all 3 names: first name, middle name, and last name. All right, so if the length of the array is 2, we want to call this constructor. Otherwise, we want to call this constructor. All right, so we'll say if next line dot length is equal to 2, we'll say students, oh, we need to make an array list actually. We need to make an array list of the class of students because we're going to be sorting that array list based on the last name later. So if next line dot length is equal to 2, what do? We say students dot add new student. In here, that will just be next line is 0 and next line of 1, right? Because first, last. This will be first, this will be last if there's only 2 elements. Otherwise, if the length is not 2, which means we must mean that we're provided all 3 names, then we'll use the other constructor of student. And that'll be simple. So how does this work? Mary Sue Smith. Either main line states the first name for first name, middle name, and last name. Okay, so if it has 3 elements, it's in the format first name, middle name, last name. So that's next line of 0, next line of 1, and then next line of 2. Okay, easy. So we have our array list of students set up. Now all we have to do is sort it using a custom comparator. How are we going to sort this? Output the names alphabetically by last name. Alrighty. So here, I'm just checking. Okay, so all of these last names are unique, but they don't specify that. So maybe if their last name is the same, then we'll sort it by first name. And then the first name is the same, then we'll sort it by middle name. Even though it doesn't say to do that here, it's just nice. And the comparator.comparing method makes it very easy to do that. So let's go ahead and do and implement this collections.sort. So collection.sort students, and we're going to use the comparator.comparing method of doing this. So remember here, we first have to specify the type of each element. So student X, right? And then we'll use our arrow notation. So the first thing we're going to be comparing by is last name, right? The last name is the one that really matters. So primarily we're going to be sorting by last name. All right. But if the last name is the same, then we're going to be comparing and sorting by first name. But if that's the same, then we're going to be comparing and sorting by the middle name. And yeah, we'll just leave it there. Otherwise, it's basically the same person, right? And I guess we need another parentheses maybe? Yeah. Okay, so we have that. I don't know why this is white. Interesting. Anyways. Okay, so we've sorted our list by last name and then first name and then middle name. Okay, so that's all good. So now all we have to do is really just print their names out. So we have to output them last name, comma, first name, and middle name if they have it. So the nice thing about us setting the middle name to an empty string is that for each element, for each student, we can go ahead and print the middle name. And if the middle name does not exist, it'll just print an empty string. So it'll be like it didn't print anything at all. So that'll be nice. So let's print out last name, first name, middle name. So we'll say students.forEach. And we're printing each one out on a separate line. And we'll say we want to print x.last. We want to print a comma and a space plus x.first plus a comma, or just plus a space, no comma. And then we'll plus x.middle. Now, if x.middle is an empty string, it'll be like it never even existed. And that'll be perfect for the people who don't have middle names. So let's go ahead and try this out. Alexander Don, Rabbit Roger, Roberts Richard Ray, Smith Larry Don, Smith Mary Sue, Stevens Linda Ann. Okay, so everything matches up perfectly. Okay, just 2 more. PR58, let's get that set up. PR58. And we need our imports, don't we? All right, we got our N, of course. Ooh. All right, so what do we gotta do? Write a program that will print a list of words sorted based on their second and fourth letters only. Interesting. So this is basically this. Okay, so basically, yeah, we're just gonna use a custom comparator on this. We're gonna have an array list of strings. Each element of the array list will be a word here from the sample input, and then we'll just use a custom comparator to sort based on their second letter and then fourth letter. And we're not going to use the compare.comparing this time, just to show you the other way we can do this. Because if we're going to use compare.comparing, then we need to make, a class, and it'll get a bit messy there. And we need to make you have to make instance variables for the second and fourth letters. So let's just not worry about that. Let's just use a regular custom comparator here. With the lambda expression. We'll use the lambda expression. Okay, so let's get this figured out. Okay, so we already have PR58 set up. We need to add each word to an array list of strings. Okay. Okay, then all we gotta do is, okay, so collections.sort words, but it's not a regular natural sort, right? We're sorting this based on the second letter first, and if the second letter is the same, then we sort based on the fourth letter. So we could, make a new comparator like that, but I think it's just a lot cleaner to use the lambda notation here. So we'll take two elements, first, second. That's what we're calling it. And then here we're going to have to return a negative value if the first is less than second, a 0 if they're equal to each other, and a positive number if first is greater than second. So let's think about this. We need to sort it based on their second letter and then their fourth letter. So let's check the second letter first. So the second letter is at index 1, right? So let's make sure that the second letter is not equal. So let's say if first.char at 1 is, okay, let's take the case first where the second letters of both words are equal, right? So that would be if first.char at 1 is equal to second.char at 1. Well, in this case, what you want to do is, now that we can't sort by the second character, you'd want to be able to sort by the fourth character, and the fourth character is index 3. So in this case, we'd say we'd return first.char at 3 minus second.char at 3. And the reason this works is, say that the char at 3 is, C in first, and it's A in second. So obviously the first word would be greater than the second word, right? Because C comes after A. So then char at 3, so the fourth character in first, minus the fourth character in second, is going to be a positive value, right? Because this is C minus A. So it's going to be a positive value, which is going to imply that first is greater than second, and the program will take care of that. Now that it knows that first is greater than second, it can rearrange the values itself. It just needs to know how to compare, for any pair that it can construct in the array list, it needs to know how to compare the two elements. Okay, that's basically what this is doing. So if the second letters in both words are not the same, then we can sort by the second letter, right? So in that case, we just say first dot char at the second letter is 1, index 1, minus second dot char at index 1. And generally, this is the way you want to go whenever you're doing these types of things, like based on characters or anything like that. You want to do the first minus the second, and usually that'll take care of what you want. Because if the first is greater than the second one, then when you subtract them, it'll be a positive number. And that's what you want when the first is greater than the second. And if the first one is less than the second one, then you're going to get a negative number, right? Because you're subtracting a larger magnitude number. And so you want a negative number when the element first is less than the second number, or the second word, whatever it is. So yeah, you want to do whenever you're doing this custom comparator technique, and it's a situation similar to this, you're going to say the first minus the second. Now the case when you'd switch this is if you wanted it in reverse order. Remember how we had collections.reverse order back then in that one problem? So if you wanted to do this in descending order, then you'd say second dot char at 3 minus first dot char at 3. But this is in ascending order, so we'll keep it like this. Okay, so now that our words are sorted by second letter and then fourth letter, all we gotta do is print them out, right? So we'll say words.forEach and system.out. Nothing special here, so we can use our nice clean notation. And I get weak tent love, work worm lost, trig trip. Nice. Okay, so that's PR58. One last problem. This is PR59 matrix sorter. Let's quickly make this class, and then we'll be done for the day. Is it the same thing here? You have two test cases. So n test cases. Okay. Write a program that will print the integers in a matrix so that the elements in each row are in numerical order from least to greatest. Okay, so that's not bad. The first line of the data set is an integer that represents the number of test cases that follow. Okay, we took care of that. The first line of each test case will contain two integers representing the number of rows and columns of the matrix in that test case. The rows of the matrix will follow in the next lines, one row per line. Okay, so we have 3 rows, 5 columns. So this is one test case, right? And this 3 and 5 is just saying 3 rows, 5 columns. Here's the actual 2D array there. Here's the actual matrix. And then you have another test case here, and it has 4 rows and 6 columns, and this is the actual matrix here. Okay, and then all we have to do, we don't have to do anything across columns. We don't have to do anything across rows. We do it for each row. So basically we just sort each row, and that's it. So this row is independent of this row. Right, so this row would be 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. Yeah, so this will be pretty easy for us, I think. So let's go ahead and get this started. So we want to scan in, we have the num rows, right? So that would be scan.nextInt, and then we have num calls. We'll just scan it in for fun, but you'll see that we don't actually need it. Okay, so once we scan in that, scan next int, we want to move to the next line, right? So we'll say scan.nextLine. Okay, so now basically for each row, all we need is num rows, because we don't need the number of columns because we can always split the next line based on the space, right? So really we're not going to use num calls, but anyway, so while we still have more rows to process, so that would be while num rows minus minus is greater than 0. Well, there's still more rows of the matrix to process. What do we need to do? Well, what we need to do is we'll take in the next line as an array of strings, but the strings will be numbers. The strings will have numbers within them. So you see here, so we'll take the next line and we'll split it on a space. So each element will be a number, one of these numbers, but it'll be in a string format. Just for now. We'll get it converted in a little bit. We'll actually do that right now. Let's convert those strings to integers, at least the data type. So array list of integer numbers is equal to new array list. And for string num in string nums, numbers.add integer dot parse int string num. Okay, so now we have an array list of the row, of all the numbers in the row. So, once we have an array list of all the numbers in the row, we just need to sort the row, right? So we'll sort that array list. So collections.sort numbers, right? Easy. Then all we have to do really is just print the row out, right? We just got to print the row out and move on to the next row. The thing is here, it says the output is a sorted matrix, and it says each column should be right justified in 4 characters. Print at least one blank line between test cases. All right, so the only thing here that we have to worry about is it has to be right justified in 4 characters, and that just calls for a printf statement. Hopefully you've had some experience with that, but if not, this is not a very hard implementation of printf, so you'll see. So for each integer in this new sorted row, right, you want to system.out.printf, and our little format string here, in order to get it right justified in 4 spaces, it'll be percent for d, right? Because we're passing it in an integer, and we want it right justified in 4 spaces. So, and that integer is going to be num. Right, so this will do everything we want. It'll take it to the end of the line, and then after that we just need to print a new line. And then we need to print another new line between test cases. So when is that? That's over here. Alright, so let's see if this works, guys. Let's see, 2, 3, 4, 5, 6, 0, 6, 7, 8, 9, -7, 1, -1, 2, 3, 8. Nice, 3, 4, 5, 6, 7, 8. Yeah, so it works great. And you'll see that all these numbers are lining up because we're right justifying, and that's why they wanted it like that. Otherwise, when you had these negatives, the negative. Otherwise, if you just said like print 3 spaces before each number, then this negative would actually be where the 7 is, and the 7 would be shifted 1 over, and so you'd have rows that are mismatching. And so using printf just makes this a lot neater, and sometimes there'll be a single problem in a UIL packet where you have to have pretty good knowledge of printf to make the format of some table or something like that, or some database that you have to print out in a nice format. So it's nice to know printf for that. But yeah, so this is right justified in 4 spaces. So this would be 1 plus 3 spaces, so that's 4 spaces total. And this is 1, 2 plus another 2 spaces, which is 4 total again. So anyways, this output matches with what we have in the problem statement. Wow, so that was quite a few problems that we did. Took quite a bit of time, but we were going over all these components of the code and talking it through. So I hope that this session helped. I hope the lecture slides helped. The video, it helped you learn different ways of sorting, different methods to go about sorting when you encounter a sorting problem in a UIL packet. There's lots of cool things like tree sets, tree maps, and if you ever want to learn a little bit more about it, feel free to just visit the Java documentation. There's a lot of things on there that might even pop up on the written test or the written portion of the UIL test. And I hope this little code walkthrough was helpful, and just figuring out how you're going to approach a problem, a sorting problem, and how you're going to tackle it in the code. So anyways, thank you for listening here and working along with me, and I'll see you in the next video. Bye.